Hey there, welcome back to our channel. Today we've got something interesting and tech-savvy to talk about. The lazy initialization pattern in Rust. I know it sounds like a mouthful, but trust me, it's an essential concept to understand when you're dealing with resource-intensive tasks. So, if you're a coding enthusiast or just curious about how to optimize your code, keep watching. Let's dive right in. You know, sometimes creating an object can be a bit heavy on your computer resources or take too much time, especially if it relies on external things like web services or databases. In such cases, it's a smart idea to create the object only when it's actually needed. That's where the lazy initialization pattern comes into play. Lazy initialization consists of three main components: the object proxy, and the expensive object. It's all about creating these expensive objects on demand. And the cool thing is, with lazy initialization, you can create multiple instances of these expensive objects, each with its own state. But hey, don't confuse it with a singleton pattern. In a singleton, you have only one instance of an object throughout the application's lifetime. With lazy initialization, you have more flexibility. You can have multiple instances of these costly objects, each created when needed. If you want more control, you can use a multiton, which looks like a singleton but allows you to manage a limited number of instances using a map or dictionary. Now, you have an idea of what lazy initialization is all about. Let's get into something real-world implementation using Rust. To implement lazy initialization in Rust, you'll need some extra precautions to make it thread safe. Let's walk through the basic implementation. We'll start by importing the necessary classes. There's only 3 lines, and there we are. Now, let's take a practical example. We're going to create a garage for expensive cars. By expensive, we mean the cost of constructing these objects. First, we implement the expensive cars struct. Also, short. There we go. These cars are uniquely identified by the color. Next, we implement the expensive car garage, or garage. Never sure how to pronounce that in English. Also, not that difficult, I think. Here's the deal. We use an arc structure to ensure thread safety. This way, only one thread can access and modify the car collection at a time. We wrap it in a mutex for this purpose. In the getCar method, we clone the car method to get a reference to the same memory location. We then test whether the key exists. If it does, we return a corresponding car. Otherwise, we create a car, add it to the collection, and return it. The mutex makes sure that only one thread at a time can access the car collection. That's what the lock is all about. Now, let's put our code to the test. This is a bit more involved, well, longer. Here in the loop, we clone our garage to have a reference to the same memory location. We create tasks to try to get the car and print the result. These tasks are then added to the vector. In the last loop, that is this one, we execute all our tasks and wait for them to finish. Let's run it. And it works. So, in conclusion, Lazy initialization can be a lifesaver, especially in scenarios where connection pooling, where creating a connection is both time and resource intensive. When combined with a multiton pattern, it offers a flexible solution to this problem. Rust makes it relatively easy to implement thread-safe solutions. Concepts like arc and mutex are well documented and straightforward to use. It's just one example of how Rust simplifies complex tasks. And that's a wrap for today. If you found this video helpful, don't forget to like, share and subscribe. If you have any questions or suggestions for future topics, leave them in the comments below. We'll see you in the next video. Happy coding!